Hello everyone, I am Dr. Shaibi, working as Assistant Professor in KPR Institute of Engineering and Technology, Coimbatore. In this video, we are going to solve few problems based upon the Fermat's little theorem. And this video is focused on finding the remainder of a huge number when it is divisible by a prime number. That is, if a number a is raised to a huge number and if we want to find the remainder when this huge number is divisible by a prime number, we will have to use this Fermat's little theorem. And this little theorem states that if p is a prime number and a is an integer such that p should not divide a, or it can be rewritten as GCD of a and p should be equal to 1. If this condition satisfies, then a power p minus 1 is always congruent to 1 mod p, or this expression is equivalent to a power p is congruent to a mod p. This holds for any integer a where such that this prime number p should not divide a. And in this video, we are going to use another theorem, that is to find the inverse of a number for a modulo p, and for that situation also we can use this Fermat's little theorem. And for this theorem states that let p be a prime number and let a be an integer such that GCD of a and p is equal to 1. Then the multiplicative inverse of a modulo p is a inverse is congruent to a power p minus 2 mod p. So in this video, we are going to use these two theorems to find the remainder, as well as we are going to solve another problem to find the inverse of a number for a modulo p. So to solve all those problems, we need to find the remainder. So here I have listed 4 different ways of finding the remainder. So I have 2 options. One is to find the positive remainder and another one is finding the negative remainder. Say for example, suppose if my integer a is greater than p and if I can able to write this a as n times of p plus r, then the remainder of the problem is r. And suppose if a is greater than p and if I can able to write as a equal to n plus 1 times of p minus r, then for that problem the remainder is minus r. And suppose if my integer a is less than a prime number, then the remainder of a problem is a. And if it is the case of a less than p and if I want to find the negative remainder, then the formula to find the negative remainder is a minus p. And here in this video we are going to solve 2 problems, whereas for those 2 problems I'm going to teach you how to find the remainder in both positive as well as in the negative form, and I will tell you if I have those both kind of situations of having positive and negative reminders, but my final answer is same. So I'm going to solve a problem and I will be finding the remainder, and I will teach you 2 different methods of having one is positive remainder and another one is negative remainder, and finally we will be getting the same answer. So let us listen carefully, and before moving on to the problem, let us have a look into it. Suppose if I have a problem of 12 modulo 13, and here the remainder is 12 because my integer a is 12 and my prime number is 13. Here I have the case of a less than p. Suppose if I want to have a positive remainder, then according to this formula, the remainder is a. Suppose if I want to have a negative remainder, and according to this formula, the remainder is a minus p. So let us have a look into this example. I want to have a positive remainder. So according to the formula, the remainder is 12. Suppose if I want to have a negative remainder, the formula is a minus p, and 12 minus 13 is minus 1. So in this problem, I can have 2 different remainders and I can solve it further. But even though I can have 2 different reminders, and finally I will reach the same destination of having a solution. Suppose in solving problems, if you have any situation of having the remainders plus or minus 1, please go with that, because having the remainders plus 1 or minus 1 is more easy to solve the problem to reach the destination solution. Okay. So here let us have a first problem. We have to find the remainder of 8 power 123 when it is divisible by a number called 17. So here, to find the remainder of this number 8 power 123, we are going to have this Fermat's little theorem. And this theorem states that GCD of A comma P is 1. And if this condition satisfies, then I can write directly as A power P minus 1 is congruent to 1 modulo P. So here P value is 17 and A value is 8. So obviously the GCD of 8 and 17 is 1. So according to this theorem, 8 power 17 minus 1, 16 is congruent to 1 modulo 17. So from now I am going to have two different ways of solving, but finally I will reach the same solution. Now let us have the first method of having the positive remainder. So let us solve this problem to find the remainder by choosing the positive remainders. Okay. So now after applying the Fermat's little theorem, this problem is reduced to 8 power 16 is congruent to 1 modulo 17. Now I want to find the remainder of 8 power 123, not 8 power 16. So to reach this 8 power 123, I want to reduce this 123 with the help of 16. So I want to find how many times of this 16 will reach 123. Suppose if it is not reaching, I want to have some kind of remainders. So 16 times of 7 plus 11 gives 123. So this expression 8 power 123 can be written as 8 power 16 into 17 plus 11. And I know 8 power 16 gives the remainder of 1 when this number is divisible by 17. So I am going to use this result in this place. So 8 power 123 is congruent to, instead of 8 power 16 into 7, I can write it as 1 power 17 into 8 power 11. Now I have 1 into 8 power 11. So now I want to solve this 8 power 11. So for that, this 8 power 11 can be split as 8 power 8 into 8 power 2 into 8, which means if I add the powers, I can end with 8 power 11. So I want to find the remainder of 8 power 8, 8 power 2 and 8 for the modulo 17. So I know 8 square is 64. When this number 64 is divisible by 17, the remainder is 13. Now I want to find the remainder of 8 power 4. For this case, I have to use 8 square, the whole square. So if I take 8 square, the whole square, this answer is equivalent to this 13, the whole square, which means always you should take the final remainder to solve further. So this 8 power 4 is equal to 13 square, and this 13 square is equivalent to 169. Now I want to check the remainder of 169 when it is divisible by 17. So the remainder is 16 for 8 power 4. Now for this case, I want to find the remainder of 8 power 8 and 8 power 2 and 8 power 1. So now I have to continue with 8 power 8. So this 8 power 8 can be written as 8 power 4 the whole square. So I know 8 power 4 gives the remainder as 16. So 16 the whole square. We all know 16 whole square is 256. When this 256 is divisible by 17, the remainder is 1. So till now we found the remainder of 8 power 8 as 1 and 8 square as 13, and we have to find the remainder of 8. And we all know this 8 is less than this prime number 17. So according to this formula, if A is less than P, and I am using the method of finding the positive remainder. So for that case, I can take the remainder as the given integer A. So if I use that particular formula here, for 8 modulo 17, the remainder is 8. So substitute the values of 8 power 8 as 1, 8 square as 13, and for 8, the remainder is 8. So if I substitute the places, I can write it as 1 into 13 into 8. So for this, the final answer is 104. If I divide this 104 with 17, the remainder what I get is 2. So for this problem, 8 power 123, when this huge number is divisible by 17, I'm getting the answer as 2 when I'm solving using the positive remainder. So next, I'm going to solve the same problem if I have a negative remainder. Say for example, let us take the same problem, but instead of positive remainder, I'm going to use always a negative remainder. Let us start with 8. Why? Because the question is 8 power 123. So to solve this, I'm going to start with a power of 8 as 1. So I'm going to have a remainder of 8 when this number is divisible by 17. I know my a is 8 and my prime number p is 17. So my a is less than my prime number p. So for this case, the formula is a minus b. So according to this, a minus 17 is equal to minus 9. So for a, the remainder is minus 9. So further, I want to find the powers of 123. Okay. So for 8 power 123, I want to find the remainder. But here I have found so far for 8 power 1. So I want to raise the remainder of this 8 power 1 to the power of 123. So this minus 9 whole power 123. We all know this power is an odd number. So minus of 1 into the whole power of 123 is always a negative number. So this negative comes outside. So instead of minus 9 whole power 123, it is enough to find minus of 9 power 123. Now let us focus on 9 powers. So we all know 9 square is 18. So when this 81, when this 81 is divisible by 17, the remainder is 13. And for 9 power 4, just square the remainders. So 9 power 4 is 13 square. So the remainder is 169. So when this 169 is divisible by 17, the remainder is 16. And now let us square this expression for 9 power 8. If I consider 9 power 8, I have to square this 16. So 9 power 8 is congruent to 16 square, which is equal to 256. When this number is divisible by 17, the remainder I get is 1. So far I have found a remainder for 9 power 8. But I want to reach till 123. So I am going to reduce the 123 with the help of 8. So 8 into 15 plus 3 gives 123. So let us rewrite this 9 power 123 as 9 power 8, the whole power 15 into 9 power 3. We all know this 9 power 8 gives the remainder 1. So this 1 power 15 into 9 power 3. So instead of 9 power 123, it is enough for me to find the remainder of 9 cube. So now let us focus on 9 cube. We all know 9 cube is 729. So this number 729 can be written as 17 times of 43, which is equal to 731 minus 2. So for this case, I told you I'm going to solve this problem with the help of negative remainder. So for this case, I'm just taking this minus 2 as a remainder. So 9 cube gives the remainder minus 2 when this number is divisible by 17. So let us move on to the question. 8 power 123 is equal to minus 9, the whole power 123, which is equal to minus of 9 power 123. And for 9 power 123, I finally ends with minus 2. So minus of minus 2, which gives the remainder 2. So if I have the positive remainder as well as the negative remainder, I'm getting the same remainder 2. And one more thing, suppose when you're finding the remainders, in any case, suppose you are ending with 1, please stop in that particular step and start finding the times of the given question power with the help of this power. Say for example, I want to find the power of 8 to the power 123, and while solving at a particular stage I got an answer of 1 as a remainder. So at this stage I have stopped, then I have started to find the times of this power 8 to reach the power 123. So this way of solving will help us more easily to get the solution. Now let us going to find the inverse of a number 337 of a modulo 101. So for this problem, we are going to have another kind of Fermat's little theorem as I have mentioned in the initial of this video. So let us recall the expression. Suppose if a is an integer and p is a prime number, and if the GCD of 37 and 101 is equal to 1, then we can use this expression according to the Fermat's little theorem. So here we all know GCD of 37 and 101 is always 1. So according to this theorem, I can rewrite the expression as 37, the whole inverse is congruent to 37 power 101 minus 2, which is equivalent to 37 power 99 mod 101. Now, I want to find the remainder of 37 power 99 with the modulo 101. So, the remainder of this expression will be the inverse of 37 modulo 101. And to find the inverse, we are going to have two different methods as well as in the previous problem. And let us have the first method called positive remainder method. So let us start with 37. Our ultimate aim is we want to find the remainder of 37 power 99. Keep it in mind. So let us start with 37. So 37 is always congruent to 37. How? This 37 is A and this 101 is the prime number P. We all know this A is less than P, so that we can take the remainder as A. Okay, so by that case I have written the remainder as 37. Now my aim is I want to find the remainder of 37 power 99. To reach this destination, I want to increase the powers now. So 37 whole square gives 1369. So when this number is divisible by 101, so it gives the remainder as 56. Now let us increase the power. So 37 the whole power 4, which means for this case I can square the 37 square remainder. That is, I can square 56 the whole square, which means for this case I'm getting the answer is 3136. When this number is divisible by 101, I am getting the remainder as 5. Now let us increase the power. 37 power 8 is congruent to 37 power 4 the whole power 2, which means I can raise the power of 5 to 2 times. So 5 square, which gives 25. Obviously this number 25 is less than 101, so the remainder is the same number 25. Now increase the power. 37 the whole power 16 is equal to the remainder is 25. So 25 square, which gives 625. When this number is divisible by 101, it gives a remainder 19. And 37 the whole power 32, which is congruent to this remainder 19 square, which is equivalent to 361. And I'm getting the number as a remainder of 58. As 367 is divisible by 108, it gives a remainder 58. Now, if 37 to the power of 64 is congruent to this 58 the whole square, which is equivalent to 3364, and if this number is divisible by 101, I'm getting the remainder as 31. Now, here you can see my aim is I want to reach the state of 99. So here I have gone up to 64. Suppose if I raise this power, definitely I will get more value than 99. But in the previous problem, at a particular stage, I have reached the remainder as 1. So when I reached the remainder as 1, what I did, I have started to make the times of the given power plus the remainder to reach the highest power. But unfortunately, in this problem, I don't have that kind of situation. So if it is a case, you have to go maximum point of reaching your power of the given question. So here I can reach the maximum of 64. Now I can rewrite the so far powers as 99 is equal to 64 plus 31 plus 2 plus 1, which means I can find the remainder of 37 power 99 with the help of 37 power 64 plus 37 power 32 plus 37 power 2 plus 37. So if I have those remainders, then I can easily find the remainder of 37 power 99. So to find these remainders, I can take the values from these steps. So for 37 power 99, let us recall the remainders what we have got. So for 37 power 64, the remainder is 31. And for 37 power 32, the remainder is 58. And for 37 power 2, the remainder is 56. And for 37 power 1, the remainder is 37. So let us take all these 4 remainders and let us have in this place. So now it is difficult for us to multiply all these 4 numbers simultaneously because we will end up with a big number. So to deal that situation, let us take 2 numbers at a time. Say, for example, I am going to take these first 2 numbers, make a product, write it here, and the last 2 numbers, make a product, write it here. Once you find the product, just divide these 2 numbers separately with 101. Say, for example, if I take this 1798, if it is divisible by 101, I am getting the remainder as 81. And if I take 2072 and if this number is divisible by 101, the remainder what I am getting is 52. So after getting the remainders, if I multiply these 2 numbers, so finally I am getting 4212. If this number is divisible by 101, I am getting the remainder as 71. So this 71 is the remainder, which means if I multiply the number 71 with 37, and if I subtract the final answer with 1, and after subtracting, if I divide the answer with 101, I am getting the remainder as 0. And this is the main essence of this problem, that is to find the inverse. Okay, so now let us have the same problem, but we are going to continue with the another method of having negative remainder method. So let us start with 37, and as I told you that I have to reach this state of 37 power 99 to find the inverse of 37 when the number is divisible by 101. So to solve the same problem, I am going to have the negative remainder method. So starting this, 37 is congruent to, I don't know what is the remainder, but I know one thing, that my number A is less than my prime number P. So for this case, I can take the remainder as A minus P. So 37 minus 101 gives minus 64. So this is the first remainder. Now let us find the powers of 37. So if it is 37 squared, I have to take this remainder minus 64. So multiplying the 64 for twice, I am getting 4096. And this 4096, if it is divisible by 101, I am getting the remainder 56. And I told you that now I am dealing with negative remainder. So instead of 56, I can take another kind of remainder, that A minus P. So for this, 56 minus 101 gives minus 45. So for 37 squared, the remainder for this problem is minus 45. Now let us increase the power of 37, the whole power 4. So for this, we have to take minus 45 for 2 times. So minus 45 into minus 45, which gives 2025. And if I divide this number with 101, I am getting the remainder as 5. And I am going to have a negative remainder. So for that, I am just having the formula A minus B. So 5 minus 101 gives minus 96. So this is the remainder for 37 power 4. Now let us have 37 power 8. So for this case, I have to multiply this minus 96 with itself. So minus 96 into minus 96 gives 9260. So when this number is divisible by 101, I am getting the remainder as 25. So to get a negative remainder, the formula is A minus P. So 25 minus 101 gives minus 76. So increase the power now. 37 power 16 is congruent to minus 76 into minus 76 is equal to 5776. So if I divide this number with 101, I am getting the remainder as 19. So to have a negative remainder, 19 minus 101 gives minus 82. So if I continue in this way, 37 power 32 is equivalent to minus 82 into minus 82 is equal to 6724. If this is divisible by 101, it gives a remainder of 58. To have a negative remainder, 58 minus 101 gives minus 43. And here 37 power 64 is congruent to minus 43 into minus 43, which gives 1849. So this number gives the remainder of 31 when it is divisible by 101. So to have a negative remainder, 31 minus 101 gives minus 70. So far I have found all the remainders as negative. Now I want to find the remainder of these four powers, that is for 37 power 64, for 37 power 32, 37 squared and 37. So for 37 power 64 the remainder is minus 70, and for 32 the remainder is minus 43, and for 2 the remainder is minus 45, and for power 1 the remainder is minus 64. So if I have all those remainders, now I want to take a product of all those four numbers and I have to find the remainder. So here I can take the first two numbers, product it, and the last two numbers make a product. So after finding the product, find the remainder of 3010 when it is divisible by 101 gives a remainder 81, and the number 2880 gives a remainder of 52 when it is divisible by 101. So finally, if I make a product of these numbers 81 and 52, I am getting the answer of 4212, which I am getting the same answer of 71 when this number is divisible by 101. So in the both methods of having positive and negative reminders, I am getting the same answer as 71. So let us verify whether this 71 is the inverse of the given number. As I told you before that, just multiply the number 37 with 71 and divide the answer with 101. You will be getting the remainder as 1. Or else you can make the product of 37 and 71. After finding the answer, subtract the answer with 1 and divide with 101. You will be getting the remainder as 0, which means the answer 71 is the correct inverse of the given number 37 for this modulo 101. And obviously, if this modulo number varies, then unfortunately because of this modulo number, the inverse also varies. So these are all the two different methods of finding the inverse. And in the previous problem, we have derived two methods to find the remainder. And this kind of solving problem is very important to crack the set examination, net and gate examination. And definitely you will be having minimum one problem of finding the remainder of this kind of situation, especially not in these exams. Similarly, for cracking the aptitude test for entering into the IT sector, definitely you will be having this kind of problems to find the remainder. And I hope you all enjoyed this video. Thank you so much. Let us meet again back in the next video.